In Lesson 10.2, Part 2, you will use Pascal's triangle and the binomial theorem. Let's look at Pascal's triangle first. Mathematician Pascal studied this pattern, 1, 1, 1. To get his next row of digits, he adds 2 digits above and writes the sum in the center below. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 0 is 1. The next row, 0 plus 1 is 1, 1 plus 2 is 3, 2 plus 1 is 3, and 1 plus 0 is 1. The next row, 0 plus 1 is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and 1 plus 0 is 1. Okay, next row, 0 plus 1 is 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5, 1 plus 0 is 1. Let's do one more row. 0 plus 1 is 1, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and 1 plus 0 is 1. So this pattern continues forever. The first row of Pascal's triangle is actually row 0. Then we have row 1, 2, 3, 4, 5, and 6 written. But of course that continues forever also, that list. Row 1 is the value you get when you raise a plus b, that binomial, to the 0 power, because anything to the 0 power is equal to 1. The digits in row 1 of Pascal's triangle are the coefficients of a plus b raised to the first power. That has a value of 1a plus 1b. The second row of Pascal's triangle are the coefficients of a plus b squared. Now we know when we multiply this binomial to itself, we're going to get 1a squared plus 2ab plus 1b squared. And then the third row must be the coefficients of a plus b to the third power then, which will expand to 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And this pattern continues. Pascal's triangle is directly related to the coefficients of binomial expansion. In example 1, we want to expand a plus b to the 5th power using Pascal's triangle. So to do that, all we have to do is use the digits in the 5th row of Pascal's triangle as our coefficients in this expansion. If we raise a plus b to the 5th power, we know that we're going to get 6 terms. And the first term is going to have a coefficient of 1. It's going to have 5 factors of a and 0 factors of b. Now the next term is going to have a coefficient of 5, and I can get that right from Pascal's triangle. It's going to have 1 less factor of a, so 4, and 1 more factor of b, so 1 factor of b. The next term is going to have a coefficient of 10. It's going to have 1 less factor of a and 1 more factor of b. The next term also has a coefficient of 10. It has 1 less factor of a and 1 more factor of b. And the next term has a coefficient of 5. It has 1 less factor of a and 1 more factor of b. And the last term is going to have that coefficient of 1. It's going to have 1 less factor of a and 1 more factor of b. Okay, now I'm going to simplify each term. The first term has a factor of 1, and b to the 0 power is another factor of 1, so it just simplifies to a to the 5th power. The next term we can write as 5a to the 4th b. And the next term will stay 10a cubed b squared. The next term, 10a squared b cubed. And then the next term can be written as 5ab to the 4th power. And the last term simplifies to b to the 5th power. So there's the expansion of a plus b to the 5th power using Pascal's triangle. Now another form of binomial expansion, another method that we use is the binomial theorem. And that uses our combination. Each coefficient is a combination in this expansion. And it can be written as the sum, as r goes from 0 to n, of n choose r, a to the n minus r power times b to the r power. In example 2, we want to expand 2x plus y squared to the 3rd power using the binomial theorem. So we're looking for 4 terms in this expansion because it's raised to the 3rd power. We know there's going to be 4 terms. The first term is going to have a coefficient of 3, that's our value of n. Choose 0, and it's going to have 3 factors of 2x, and it's going to have no factors of y squared. Okay, the next term is going to have a coefficient of 3, choose 1. It's going to have 1 less factor of 2x and 1 more factor of y squared. The next term is going to have a coefficient of 3, choose 2. It's going to have 1 less factor of 2x, and it's going to have 1 more factor of y squared. Okay, and the last term in this expansion is going to have a coefficient of 3, choose 3. It's going to have 1 less factor of 2x and 1 more factor of y squared. Okay, so now we need to go back and simplify. This combination can be written as 3 factorial over 3 take away 0, which is 3 factorial, 0 factorial. Okay, 2x cubed can be written as 2 cubed x cubed. And y squared to the 0 power, anything to the 0 power has a value of 1. Okay, the next combination is 3 factorial over 3 take away 1, which is 2 factorial, 1 factorial. We have 2 squared x squared, getting rid of parentheses. We have y squared to the 1st power, and that's just y squared. The next term, our combination is 3 factorial over 3 take away 2, which is 1 factorial, 2 factorial. We have 2x to the 1st power, and we have y squared squared, that's double exponents, we multiply, so 2 times 2 would give us an exponent of 4 on y. And in the last term, we have 3 factorial over 3 take away 3, which is 0 factorial, 3 factorial. We have 2x to the 0 power, which just has a value of 1. We have y squared cubed, double exponents, we're going to multiply again, so we have 2 times 3, or 6. Going back now and simplifying our fractions here, we'll cancel 3 factorial top and bottom. 0 factorial has a value of 1, so this coefficient is 1. We have 2 cubed, which is 8. 8x cubed is our first term. Okay, in the second term, we can expand our factorial. We have 3 times 2 factorial. We'll stop there because we have 2 factorial in the denominator, and 1 factorial has a value of 1. Okay, we have 2 squared, which is 4, so we have 4x squared y squared in this term. Okay, then we'll expand again our factorial in the numerator. So we have 3 times 2 factorial over 1 factorial, which has a value of 1, 2 factorial. And we have 2xy to the 4th in this term. And in the last term, we'll cancel 3 factorial top and bottom. 0 factorial has a value of 1, so this coefficient on y to the 6th is just 1. Okay, one more time. Simplifying, we have 8x cubed. Okay, here we can cancel our 2 factorial, so we're left with 3. 3 times 4 is 12, so this term is 12x squared y squared. Okay, then in our next term, we'll cancel 2 factorial top and bottom. We're left with 3. 3 times 2 is 6, so that's our coefficient on x, y to the 4th. And our last term is 1 y to the 6th. So there's the expansion of 2x plus y squared raised to the third power using the binomial theorem. In example 3, we want to find the coefficient of x to the 7th in the expansion of 2 minus 3x raised to the 10th power. So let's pick out our a value. It's going to be 2. Our b value in this expansion is negative 3x. Our n value is 10. And our r value is 7. We want to know what the 7th term in this expansion is going to look like. So we can use our sigma notation to find that term. We would have 10, choose 7. A is 2, so we have 2 raised to the 10 minus 7 power. B is negative 3x, and that's going to be raised to the 7th power. Okay, so simplifying, 10 choose 7 can be written as 10 factorial over 10 minus 7, which is 3 factorial, 7 factorial. 10 minus 7 is 3, so we have 2 cubed here, which is 8. And then we have negative 3 raised to the 7th power, x to the 7th power. So you can see that if we want the coefficient on x to the 7th, then we're going to simplify what we have here. So simplifying, expanding that factorial in the numerator, we have 10 times 9 times 8 times 7 factorial. In the denominator, we have 3 times 2 times 1 times 7 factorial. We have 8, and we have negative 3 to the 7th power, which has a value of negative 2,187. And then we can go back and we can cancel our 7 factorial top and bottom in this fraction. 2 goes into 8 4 times, and 3 goes into 9 3 times. So we're left with 10 times 3 times 4, which is 120. So we have 120 times 8 times negative 2,187. And if we multiply using our calculator, we're going to find out that that has a value of negative 2,099,520. Include with your notes of this video guided practice problems 8 through 12 even on pages 693 and 694 of your textbook.